Hello, everyone, and welcome to the last formal session of our Road to Certification Professional Cloud Developer Certification from GDG Lawrence. My name is Roman. I'm here also with Kevin Kwan from GDG Lawrence. We have all other communities joining us, but yes, this is our last session of this campaign. I hope you have been keeping track of all the sessions that we've been doing. Please join us on our you could join us on our YouTube channel at GDG Lawrence. I don't know if you guys knew, but we also have an Instagram. You should be able to follow us on the IG, on the Instagram. We should be able to add more content in there, but we're going to start giving some love to that. But you can join us on Instagram as well. Of course, we have a presence all over the place. But thank you everybody for joining throughout this series. This is the last official formal session for this campaign. Yes, let's continue proceeding. And again, of course, thank you. This wouldn't have been possible without all of you. Thank you so much to all the neighboring communities. Like I mentioned, GDG Hudson, which is going to have their Dev Fest this weekend, Dev Fest Troy 2025. Please make sure to sign up. I'll be there. Also, all the other communities, GDG Capital Region, Linda's here. I know Carol is also joining us all the time. So thank you so much for all the GDG communities in Florida and whatnot. So thank you everybody for making this happen. Without you, we wouldn't be able to make this happen. So thank you all the co-hosting communities. Yes. Can you believe it? Can you believe it? We are already at week 6. We are already at week 6 and we completed all of this. Like, it just time flies by whenever you're having fun. So that is the reason why I love again doing this every single year in a successful manner. You can take a look at how many people have completed all their assignments. I think this is a record. I don't think we've had this many people complete all of their badges in one campaign. Kevin is like topping the lead. We have about 10, 15 people already completing, and you have until next week to complete them all, because after that, then we're going to lock it down. And, whichever, whoever completes it by next week's last of office hours, should be able to get one voucher to get the certification. So we're still working out the details on how we're going to distribute it. But again, we're working that out with the team at Google. But if you complete all the badges by next Wednesday, then after that, we're going to lock it. And we need to do that. But then we're going to have one final session, which is just the voucher ceremony. That is where we're going to announce everybody who's going to get a voucher and whatnot. So, and we're going to do some raffles as well. So please make sure to join us for our last voucher ceremony, where we will celebrate all your accomplishments. Thank you so much. Thank you for all your hard work. I see a few of you have more to go. Yeah, you still have one more week. Yeah, please keep on going. You still have 1 week. You have 1 week. So make sure, otherwise then we'll lock it down and this is it. So thank you so much. But even though you haven't completed them all, you may get a chance to get into a raffle, so that we can get raffle we're gonna raffle like about 3 vouchers among everybody who has completed a certain amount. Like if you've completed all the 12, then you're good. But then if you completed, for example, like 10, between 10 and 8 or something, then you could be within that pool of people. The rest of the people, will raffle stuff among everybody. So yeah, so you should be at week 6, and at week 6 it was kind of like a little bit of a review of what Kevin and I had been discussing for the previous weeks, where we talked about deploying to Kubernetes. But this was a very lab packed week, right? There was a lot of labs, like on Apigee, on on Cloud Run, on Kubernetes. There was a bunch of labs. I think it was like mostly to solidify all the knowledge that you had accumulated throughout the campaign, and then you needed to apply it in a kind of like in a hands-on way. Okay, so make sure that you have completed all those labs. There are some challenge labs, so make sure to let us know if you're having issues on any of those. Okay, so but we should be already at week 6. If you're not, like I mentioned, you still have a little bit of time to complete some of those. Okay, awesome. Great. Yes, please enter today's raffle. The QR code and the links are the ones for tonight. Make sure to join our raffle. Kevin, I don't know if you can maybe type it up in the chat, or I can just even give you the I probably could give you the link and then we could drop it in there, right? So this is you go to tinyurl.com/RTC PCD6, which is very easy. But again, it's only for the people who are joining live. If you're watching this on YouTube, sorry, this is the reason why you got to join our live sessions, because then you could get cool swag from us. So please join our raffle. Kevin is going to drop it in the chat. I'm going to be sharing the slides at the end of the session. And Kevin, can you pin it at the top of the chat? That way people know that throughout this session, you can join the raffle. We're going to pick 2 winners, and then you can pick one of the items in the list. Okay, so good luck to everybody. Thank you, everybody, for joining the session. Now let's proceed and let's do kind of like a review, right? So one of the topics that we were covering throughout this in this specific week, which is the last week, it was deployment to Kubernetes. So deploying Kubernetes applications on the Google Cloud. So this is going to be a review for those of you who did it, and this is going to be a preview for those of you who haven't completed it. And then that way, I'm not going to spoil too much because it's so much fun, very charged with, packed with a bunch of labs, like I mentioned. So what do they talk about? So they're talking about containerization and orchestration. They introduce you to Docker. So you do build stuff on the Google. You build stuff on the Google Cloud. You build containers, and they explain about like what is containerization. Can you guys hear me well? Can you guys hear me well? Just wanted like either a thumbs up or. Awesome, great. So let's continue. So yes, they talk about Docker, how to Dockerize, containerization, Docker fundamentals, and whatnot. They talk about a lot of Google Kubernetes, right? So they talk about what's Kubernetes, what are all those all the things pretty much what we covered. They covered also. Okay, here we go. So yeah, they did like a really like a deep dive on that about like how to orchestrate microservices, so you truly get into the hands-on experience on how to build these things in the Google Cloud. And last but not least, they do like advanced deployment techniques, scaling and management and whatnot. There was a bunch of things around that. So now they talk about, for example, how you package applications for portability. So again, this is just a review. Most of you should already be familiar with all of this. So they say, why containerize? So why is it? Because of the portability. Why? Because you can run consistently across different environments, development, test, production, the whole works on my machine now becomes works everywhere because you have that consistency and that predictability, right? Containerizing your applications gives you that isolation. So applications and their dependencies, they're isolated from each other and the host system preventing conflict. So it gives you that benefit, right? Efficiency. The part of the efficiency is like the containers all containers share the host OS kernel, making them much lighter and faster to start than virtual machines. Like right now, a compute engine virtual machine, yeah, they're pretty lightweight, they're pretty cool, but still Dockers take the cake when it comes to being much lighter. Right. And last but not least, the scalability. So containerizing your applications makes it easier to scale out applications by spinning up more identical containers. And they're very fast to to boot up, right? They talk about, again, storing and sharing your container images. I don't know what you guys are using right now, but I use a lot. For example, again, I use the Docker Hub. I also, in the Google Cloud, I use the Artifact Registry, which I think it used to be called Container Registry. Now they call it Artifact Registry. So the Docker image, again, the Docker image is that starting from that concept. So the way that you store your images, right? You start with the Docker image, which is that lightweight and standalone executable package that includes everything that you need to run your application, right? Images are composed of layers, which represent each instructions in the Docker file. We're going to go into that in just a second. We could even do like a quick lab, and then I'll show you how to do that. Images are composed or layer, like I mentioned. The layering enables efficient storage and sharing. The Docker registry, which is, again, that centralized repository for Docker images. It's kind of like it equates what Docker Hub is. The public registry, like Docker Hub, like I mentioned, is the most popular public registry out there, and it hosts countless official and community contributed images. I've actually even created my own images, and I've posted them on Docker Hub, and then I reuse them from there. And of course, private registries such as you have, I know you have like Amazon Elastic Container Registry, you have Azure, Azure has its own, and of course, Google has their its own container registry called Artifact Registry. And then Artifact Registry, like I mentioned, is just Google's universal package manager that supports Docker images, but it also supports other artifact types, right? Good. So then they talk about orchestration, talk about a lot of Kubernetes during these sessions, and they talk about like what are the benefits of that. So what is the orchestration? So orchestration, for those of you in the world of containers, right? The orchestration meaning as you scale containers, managing them individually becomes really complex, right? Orchestration automates the deployment, the scaling, the healing, and the management of containerized applications. So, what does Kubernetes, comes into play? So, Kubernetes is an open source system for automating the deployment, the scaling, and the management of containerized applications, making it very streamlined and very even automated. It groups containers that make up an application into logical units for easy management and discovery. So it kind of like gives you this whole package where you can manage all the pieces that and like represent your application, but as discrete features and functionalities divided into containers, but can be considered a unit, right? What is GKE or Google Kubernetes Engine? Sorry, Google Kubernetes Engine. GKE is Google Cloud's managed environment for deploying, managing, and scaling containerized applications. There are great benefits to it because it's fully managed. It has automated operations. Again, it does like old automated upgrades. You don't have to deal with that. Patching, repairs for master and worker nodes. Remember, like the nodes in a Kubernetes engine cluster, they're actually compute engine instances. The scalability is pretty flexible because it seamlessly scales your cluster resources up and down based on demand, based on traffic. And the integration, like there's deeper integration with other Google Cloud services, for example, like networking, monitoring, and security. So there's a lot of really cool things. They mention about the kubectl. I don't know how you guys call it. The command for the command line tool for Kubernetes is called kubectl. People call it kubectl. I think it's a funny name. Kubectl. It's a cute name, so I call it kubectl, which is the primary command line tool for interacting with a Kubernetes cluster, whether it's either local or GKE. You could do that. Of course, you could do like a basic deployment of that. You have to create the GKE cluster. Remember, you provision those instances, those compute engine instances that will run your containers, like your nodes are actually the compute engine instances. Then you configure kubectl. You connect your local kubectl to the GKE cluster. You deploy your application, of course, using kubectl create deployment to deploy a container image. You expose your application to the world. You use kubectl. I think you do kubectl expose deployment. You specify, you put a name, you specify whether it's a load balancer, and then you have like other options. I think we were talking last week during the session, kubectl make money. I would love for that command to exist. Yes, and then of course you verify the deployment, you get the pods, you get the deployments, you get the services, and then you check whether your deployment was successfully created, right? So it's pretty cool. If I open up, for example, like if I go to console.cloud.google.com, and then let's say if I open up my my Cloud Shell right there, even if you open it up, I'm going to just zoom in real quick, and then I even do like Docker. See, Docker is already part of your Cloud Shell experience, right? Here I can even come up and say, for example, see, this is my home directory. I'm going to create actually a folder. Let's create a folder, and then I'm going to call it sample service. I'm going to cd into it, and I'm going to use Gemini. I know that we haven't used Gemini that much. We've been doing a lot of like simple stuff. So why don't we create like a simple Docker image based on a Docker file, and then I'm just going to show you how you can immediately start doing stuff right there in the Google Cloud. Very simple, very easy. So here I'm just going to say create a Docker file for a simple, let's say, web service, probably using Nginx. We could say, perhaps using Nginx, and just let's say spitting out the word hello. Let's say the phrase hello world after deployment. First, let's create the Docker file. So I'm assuming that it will create that Docker file. We'll probably then move it wherever it needs to do. See, it's just going to create let me say, allow this change. Yes, allow. Okay. So it should create the Docker file that represents kind of, see, it already, see, I'm going to continue saying this. We're going to go over real quick, and then I'm just going to show you. I think it's going to create just like an index HTML with the word hello world. We're going to make it into an image first. Then we're going to build the image into a container, and then we're going to run that container, right? So we could do it right here, right from the right from our cloud shell, and then you should be able to see it. So you see summarizing the instructions and all of that, and then you see how simple it is. I could have written it by hand, but of course that's the reason why you have Gemini, because these things could be created even automatically. So let's see what is, so it's trying to create everything for me, but you will see how the Docker file represents. So the Docker file is that configuration that specifies what are the dependencies that your container will require, and then you'll use that at the root of the folder or wherever you have your application. So it has to be at the root. You could also do like a cloud build YAML, which is even a more comprehensive configuration file that you can use to automate the whole thing. It also builds your container on the cloud. It creates the image. You can even deploy it to artifact registry, and then you can even deploy it, let's say, to Cloud Run. You could do all of that. So let's see how it's coming out. So I can even open up the editor. I could have done it with the editor, but that's fine. I'll just try to open that, and you see, let me see. I think I created the sample service. There's my Docker file. There it is. And the simplest thing it did is just create just it says from Nginx. Nginx meaning is that core image that I'm going to use as the foundation for my own image. And it's just gonna create just an index HTML that has hello world. I'll probably just make it more. I'll just create a simple. I'll just say doc type HTML. I'll do an HTML, and then I'm gonna do body, and then I'm gonna do it prettier. I'm gonna do an H1, and then I'll put hello world. I'll save that, and then you see that's my Docker file. So in order to build a container, again, I'm just gonna go really easy because this should be known already by you. But if you don't know, that's okay. Remember, the way that you build an image, you have to say Docker build. You say, for example, you tag it with a name. I'm going to call it sample service. And then you're going to say which files is it going to use. It's going to use everything within this folder. So you just do that. That means is build a Docker image based on this, whatever is in this folder. So whatever is in there. Failed to read Docker file. What is it? Oh, okay. Sorry. I need to go in there. Here we go. Now I say, I'll run the command one more time. Docker build sample service. That's it. So I'm going to build my image. If you remember, the Docker file needed to be at the root, right? There it is. I could have also done something like expose, let's say, for example, like 8080. Like if I want to, I want to expose like one particular port, but I think it does that on its own. I think that's just like documentation only. If I say Docker images ls, see, it says no images found. Oh, sorry. I do Docker images, and then it shows me that my image is already created. Now all I need to do is say Docker run, and I'm going to grab that image. I'm going to build it as a container, and then let's see if we could just preview it right here. So remember, in order for you to then grab this image and convert it into a container, it's just, you have to say Docker run. -d means in detached mode. And then if you're going to use your image, then you're just going to say sample service, right? Sorry, sample service. And you can even give it like a name. And then you could do, for example, like sample service, right? To that container. So if I do that and hit run, see, wait a see. Oh, I need to do, give me 1 second. If I do Docker images, my images, sample service. So let's try it again. I'll do Docker run -d sample, sorry. well, it's actually the latest, so it should be that the tag should be sample service. There it is. So is running my container. I'm assuming that it should be already let's say exposing like the port 80. So if I come over here and do preview on port 8080, let me see if it does that. Okay, so I need to actually specify. If I say docker ps, this is to check any running container. If you want to kill the container, so you do docker kill, and then you specify like the container ID, and then it kills your container. But I need to run it again, and then I have to specify the port. So I do docker run -d, I do -p, so I could do port 8080 exposing port 8080. That way you're saying that the inner port 8080 is mapping to an external port 8080, right? And then now I'll say sample service. Now I'm going to use that same image that I already created, and then now I will run my container. So let's just hit enter. It should run. Now if I do and you see it run in detached mode, that if I do that, let me see, can I connect to server port and ensure you select that with an HTTP? Okay, so I need to make sure that, let me see if my container is running, docker ps, that's my container. There it is. We just need to make sure that I think I need to also, I can even go and here like docker ps, that's my container running. Let me make sure that I do preview port 8080. Let me see. I think it says unable to forward request to a backend. Okay, so I can take a look at that later, but you should be able to I probably then had to say expose 8080 or actually expose port 80 from inside of Nginx, so that then I can map it to the other one. But I could do this, and I can try it again. But at least I just wanted to make sure, I just wanted to show you like how simple it was for you to, for example, like create just a simple container out of anything, and then you could just build it. Also, a way for you to, let's say if you have this container locally and you still want to build it in the cloud and deploy it to Artifact Registry, you can submit it as a cloud build. The way to do it, you do gcloud builds submit. You could do this submit, and then you do dot, I believe that's the command. And what it's going to do is going to build it. Is instead of building it locally, it's actually going to grab the bits from your project, and then it's going to build it in the Google Cloud, and then is going to just generate that build, but in the Google Cloud, as opposed to being like local on your local environment. Yeah, I think it's hanging in there somehow. Gotcha. Okay, I'm just going to kill it just for now, but I just wanted to show you the command. So if you go to the gcloud, if you do like gcloud builds, and then you do help, it shows you, for example, like all the, why is it hanging? Like all my stuff is hanging now. But anyway, make sure that you could, for example, like take a look at all the commands that you can do. But if you do, like I mentioned, was I here in Gemini before? Gemini, yeah. Let's do Gemini again, and then I'm gonna see if I could do the. I'm gonna tell Gemini actually to deploy this into, like, to create an image and deploy it to Artifact Registry. But I think I have to have Artifact Registry API enabled for this to happen. See, I don't know, for some reason things are hanging for me. I'm gonna have to take a look at my environment. I'm gonna stop it right here. But again, it's so many things that you can do in the Google Cloud right from your Cloud Shell terminal. For some reason, I'm having some technical issues in here. I see even my Docker's like now acting up. But anyway, let's go back to the presentation. So again, there's so many things that you could do. Again, with kubectl, with containers right in the Google Cloud, and you can just do a lot of cool things in it. They talk about, again, Kubernetes, like I mentioned. They talk about all the concepts about, what are pods, what are deployments, what are services, right? In order to know about Kubernetes, you need to know all those concepts. So you need to know what are pods. So pods are the smallest deployable unit in Kubernetes. Deployments are actually what manages the life cycle of the pods and ensures that a specified number of pods replicas are running. Remember, a pod is just a pod could be either be one container or multiple containers that communicate with each other that maybe are related to one another, right? It's either but it's a running instance, a single instance of a running process, which could have one container or more than one container. And services, which are an abstracted way to expose an application running on a set of pods as a network service. That way you don't have to know like the internal IP addresses or anything like that. You just access the service, right? Now to my favorite topic, which are serverless applications on Cloud Run, which is what I love the most. So I love serverless. I love Cloud Run. So this is something that again, I definitely had a lot of fun on this section right here. So they talk about Cloud Run, you know, the power of managed serverless containers or whatnot. Cloud Run, again, is that fully managed compute platform that enables to run serverless containers, stateless containers via web requests or pub sub events, right? It abstracts away all the infrastructure management, allow you to focus purely on your code, and you can just create them like very simple. What are the key features? You know, any language, any library, of course, because you can run any code. You can create your own containers. For example, like that service that I created, I could have just run it as a Cloud Run service. Very simple. Auto scaling is one of the things that I love the most about it, because they scale instantly from 0 instances, saving you money because you only pay for what you use. You only pay for when they execute, up to thousands of Cloud Run instances based on traffic, of course. And they follow that pay per use model, because you only pay when your container is actively handling a request. And if you come over here to the Google Cloud, they're very easy to do. If you just come up over here and go to Cloud Functions, Cloud Run Functions, you can just create very simple one. Look, I'm showing you like all the batch tracker is actually powered by the Google Cloud. You can create a quick function real quick, and you can just say, I want to create the inline editor to create a function. You give it the function name. You could call this, you know, RTC GDG Lawrence, you know, function. You specify which is the region where you want to deploy it. Let's say you usually pick what's closer to you. For example, I'm going to go like with US East 1. This is the endpoint that is going to give you. You pick which is you pick the runtime that you want to do. For example, you could do Node.js. If I say allow public access, that means it's not going to require any authentication. And we just keep it request based. That's okay. You have to specify the minimum number of instances and the maximum number of instances. Let's not do manual scaling. You want to do auto scaling all the time. You can base it off of a container if you already have one. Base it off of an image, and then it creates a container, all of that. And then I'm just going to hit create. But I actually wanted to do the... let me see. I think it's gonna allow me to do just an inline editor. Yeah, that's exactly what I want to do. So if I hit create, it's gonna then allow me to type anything. There it is. So I'm gonna just say hello everyone from GDG Lawrence, for example, and I'm just gonna send like that string regardless of the request. I'm not gonna do this. I'm just gonna say that. So let me make sure. So again, creating cloud functions in the Google Cloud is pretty easy, and some of the labs focus also on this. So let me just save and deploy. I'm gonna drop the link in the chat if you guys want to take a look from your end, so that you see this is not a gimmick. I'm actually creating a Cloud Run function right on the fly. You see how fast it is. You're able to create services which are completely serverless, completely stateless, and be long gone are the days where, oh, you have to put a ticket and you have to do a bunch of things in order just to have one simple service running. Even complex services, you can have them running in no time. So you'll see once this deploys, you'll see how it actually gets created. What I love about Cloud Run functions is that you could also control traffic. You have a lot of observability. You could, check logs, check the performance and whatnot. So if you see, you can use them as jobs. You can use them as being triggered by a cloud scheduler. They can be part of your workflow. Remember when we were talking about multiple service orchestration or choreography, all of that. So let's see if it works. I'm just going to click here, and it says, hello, everyone from GDG Lawrence. I'm going to drop it in the chat. Revisions is pretty good. Also, the traffic splitting, it's pretty good. Thank you, Jose, for bringing that up. But yes, if you just click on that, you should be able to see on your end hello everyone from GDG Lawrence, because it's very easy. This is already public. This is already deployed, and it's not going to cost me anything because cloud runs are free until like 1 million executions a month. So if you're not using cloud functions to create like your own services, you're throwing money. You're definitely leaving money on the table. So cloud run functions are pretty good, and they're the way to go whenever you want to create like serverless services and whatnot. Awesome. Developing REST APIs with Go. That's another lab that we went over, which was pretty cool. And they talk about how you build high performance serverless backends. We talked about Cloud Run, and I showed you how you can use like the Node.js runtime, but you could use Go. Go is actually a very popular language. It's like supposed to be the replacement of C++, but it's very high performant, and you can create RESTful APIs, very efficient RESTful APIs with Go. So what is a RESTful API, you may be asking? So again, RESTful API, REST stands for representational state transfer. And it's a type of API. It's a set of standardized rules pretty much for defining how web clients communicate with a server. Remember, typically using the existing HTTP protocol verbs, those HTTP methods such as get, post, put, delete, and then you specify how your APIs look. So why would you do like Go on Cloud Run? Remember, I told you you can do many languages, but the fact that you can use Go on Cloud Run is for many reasons, mostly performance, because Golang is known for its speed, concurrency, and low memory footprint, which is pretty good, making it ideal for microservices. Node.js, Python, you can still use them, but they're a little bloated compared to Go. So they give you that. Yeah, Go, like, please copy Jose, what Jose is doing. Do a copy paste on whatever he's saying right there. It's actually a must to learn as a cloud developer. Yes. That's exactly, if you want to be a cloud developer, you want to do really serious stuff, you got to do Go. Also, Go is being used even for embedded applications. It's been used for backend, for running running workloads locally. So as a cloud developer, you want to learn Go. It opens up a lot of doors. And if you want to build performance applications, you got to use Go. So thank you, Jose, for making that question. And yeah, Python is good. It's not going away. It's pretty good. It's a good starting language, but Go is like, you want to take it to the next level, you go with Go. Very good. And very cool when you want to use it, for example, like in a Cloud Run function. Of course, combining Cloud Run and PubSub. Remember, we talked a little bit about PubSub when it comes to like as a service orchestrator, as a message broker. So then how does it play well with Cloud Run? How does it do it? So first, what is PubSub? PubSub is is Google Cloud's PubSub, is that global real-time messaging service. And it allows for independent applications, like, again, the pub sub. So independent applications or publishers to send messages to other services. Again, the subscribers. That's the reason it's called pub sub. So you have publishers and you have subscribers without knowing who the receivers are. This allows you to build a very decoupled. Remember again, if you use, for example, those terms like out there, like decoupled, independent, isolated, distributed, those keywords are not just like cool words that you could put on your resume. That's really something that you should live by, because it truly decouples services and increases resilience and makes them, for example, every service could have its own life cycle, can have its own let's say it has its own release cycles and whatnot. So it provides resilience. Why? Because let's say if you PubSub is based on like topics. You set up a topic and you create it like a subscriber. And then whenever you put something on that topic, whoever subscribed to that will receive that message. No two services will know about each other and they can grow independently, but at least they will use that channel, that message broker, which is PubSub, using a topic to communicate. So that's something that you should leverage about that. So did I skip one slide? Yeah. So make sure, and then if you want to see PubSub in action, remember, if you just go here and you do PubSub, it's very easy to use. For example, I could have done a simple test right here, but the main thing that you need to do is you create a topic. So you give it an ID, and then, for example, actually ID should be more explicit. For example, you could do GDG Lawrence topic, and every time that for example, like I can publish something on this topic, and then if I have a subscriber on this topic, that subscriber will kind of receive it in a push fashion as opposed to pull. You're not doing any polling. You actually receive a notification, and then you receive that value, and so on. And then you could just do create, and then it's simple, just like that. So that's why I love Pops Up, because it allows you for that. If you review the topic about microservices, Pops Up is there, and also Event Art. Remember. Yeah, they talk about the serverless development pipeline. Again, I think that was the final module on the part of like developing cloud run services on the Google Cloud. So they talk about like how they integrate the development and deployment workflow. They talk about Cloud Build, like I was mentioning. You learn how to use Cloud Build to fetch source code. I wanted to do a build for you, but again, my machine was acting up my Cloud Shell, but you should definitely have enough time to play around with some of the labs that are already there. You could do this, the store, for example, you can build your images, you can store them in Artifact Registry, and then you can use those images to create Cloud Run instances, as opposed to like do what I did, like I typed code in line. You actually can use already pre-created images by you that are built by Cloud Build. So very, very, very good. Yeah, let's continue. So again, then the last topic, I think it was, they were talking about Apigee. I'm going to be honest with you, and I'm going to make a confession. So I didn't know much about Apigee, and I'm like, I don't need Apigee. I think I've been doing really good the way that I've been doing. But when I get to learn Apigee in this session, I'm like, how is it that I've been living without Apigee? And ever since, I've been doing Apigee like crazy. Apigee is amazing. And I'm like, why haven't I done Apigee before? I've been using API Gateway. Again, these gateway services, what they provide is kind of like a proxy in the middle between your backend and your clients. And then, for example, I've been using API Gateway, which is free. It's not free, but it gives you like really good it gives you really good quotas, and you can implement it on in front of your backends. You can even mock services and whatnot. You can just put a gateway in front of your existing services, and API Gateway will be really cool. It's based on OpenAI specification of how you specify like your endpoints. It uses even Swagger 2.0 so that you can define your endpoints in a very seamless way, in a very automated way as well. And you like a very well-defined documentation. Have you guys done, for example, like Swagger? Look, if you go to Swagger editor, I was already doing something here earlier, and I was like building my own API. And for example, I was building an API, and I'm using this Swagger 2.0 specification. You use the Swagger 2.0 specification, which allows you to define what your endpoints are. And this is exactly pretty much what API Gateway supports. You grab this Swagger Open API, define how you define all your endpoints, what your endpoints receive, which requests you can make, whether it's a get, whether it's a put, what type of payload, and all of that is pretty good. But then when you use it with Apigee, it's like everything is in there, and it gives you then some. So Apigee, if you haven't used it, it's a little bit expensive, but it's worth it if you want to try it, because it gives you a lot of functionality. Let's take a look at a little bit of that. But yeah, Apigee is really crazy. I'm like, how have I been living all this time without Apigee? It's because Apigee, I think it was acquired by Google. But yeah, it's a must. Like Kevin says, like it's a must if you want to deploy secure web applications. It does, for example, it enforces policies. It gives you, for example, enforces even like headers, does a bunch of automations behind you. It does a lot of security, which is pretty good. Like even generates like tokens for you. It inserts tokens. You can automate things. It does validation. It does wow, you can even do which is actually the key thing of Apigee is the monetization. We're going to go into that, but it's pretty cool. So yes, again, we talk about a lot of APIs and all of that. So what is an API? It's called Application Programming Interface, and it's just a set of defined methods and protocols that allow you to differentiate software components to communicate, how software components can communicate with each other. It's kind of like an interface, how your service defines which operations you can perform against it, whether you can do it via a particular protocol. Is mostly commonly used using like the HTTP protocol, but you can define an API, for example, for like gRPC or WebSockets or something like that. It does usually follow that client server model. It uses that request response communication, typically using, like I mentioned, like HTTP requests, using a structured response, whether it's JSON or XML. In Google Cloud, APIs are the primary method for interacting with all the services. Did you know that? And pretty much everything that you could do in the Google Cloud via the console, you could do it through an API. So it's pretty cool. But again, Apigee, we're here to talk about Apigee. So Apigee is Google Cloud's unified API management platform designed to help organizations secure, manage, and scale their APIs across hybrid and multi-cloud environments. It acts as an API proxy, like I mentioned, kind of like API gateway, like an API proxy layer in front of your backend services. You can have like a bunch of, like Google Cloud functions, but then you have one gateway in front of it, which points to all of your cloud functions, and then it makes it look to your client like it's one single API, when you can have like a ton of cloud functions. Even maybe you can even have a service hosted on a cloud, on a compute engine instance running Cloud SQL, but you could actually point it to a service in there and your users won't even know it. So it's pretty good. So it's great for backend service deployment. Is great for shared workflows. You can create like reusable logic blocks. I think in the labs they do share that, called like shared flows. You can handle common tasks, like again, like I mentioned, you can retrieve cached content, promoting reuse and efficiency. And one of the cool things is the policies that I mentioned, the policy modification based on JavaScript. So you can use inline JavaScript code within the Apigee proxy to modify an API request. You can do like massaging of the API request, the request and the response payloads before it reaches your backend, and you can sanitize the data. I think that's another thing that you can implement, like sanitization. Another thing, I guess, this is what I was mentioning a lot, like the monetization thing. So the monetization of the Apigee is like one of their key top features. So why publish your own API? So APIs are often productized and offered to external partners or internal teams. I've built APIs only for my own internal applications, but successful publishing requires structured packaging in a friendly interface for discovery, of course. And usually if you want to create an API that you want to make money out of, you could use something like Apigee. And it is great for like packaging, like I said, like a packaging an API. Like you can provide like a premium plan or like a free plan or like a basic plan, and then you provide like API keys that you distribute to someone who maybe has purchased that, and then you give them access to your API. So that's a way to monetize. And of course, Apigee provides that, protecting data, and of course ensures stability via, let's say, OAuth security. So it does, like all that security, like distributing OAuth tokens instead of simple API keys. You can do just an API key, but an OAuth tokens is actually more secure. It provides a more standardized, more secure method for delegating authorization. As far as the implementation of OAuth security, you can use policies, like I mentioned, to validate token. I think I mentioned that already, but you could do validate token authenticity and scope before forwarding the request to your backend, and it makes it more secure. So Apigee is like a one-stop shop to secure your backends, and also to prevent like malicious attacks. Also it actually even throttles like calls. Like if you see that somebody's hitting your endpoints like a certain amount of times, it doesn't even reach your backends. It actually just hits the API, the Apigee API gateway, the proxy, and it just blocks your users before it even reaches the backend. Let's say if you have data that is frequently fetched by your users, instead of hitting your backends directly and eating up on your quotas and your data and your cost, Apigee sets up a cache so that it only hits your proxy, and then you get the same result, and it ensures that idempotency that is usually needed in certain APIs. So it's pretty good. I see a couple of questions in the. See a couple of questions in the chat. Can I provide a quota for specific keys to the panel? Yes, Jose, you are correct. You can specify quotas for specific keys. You say this key is only for certain users, or this key only allows you 1,000 calls a month, and after that you're blocked. You can actually do that. Very cool. You can even set up set up other rules like associated with those keys. Like if you're in Europe, you cannot access this API and stuff like that. There's a bunch of things that you can do. And the great thing is that nothing hits your backend. Everything remains within Apigee. So you can use that API Gateway. I use API Gateway because it's pretty much free. But if you use Apigee, yes, you got to pay, I think it's like 50 cents per day. I think it is. I don't know. It's a little pricey, but it's good if you're truly serious about monetizing your APIs and making something secure. Companies should be able to invest on something like that. So Apigee is the way to go. Like I said, I didn't know about Apigee. I was going to be honest. And I'm like, now is the best thing since sliced bread. So Apigee is the way to go. Another question, what about SSO for users that need to authenticate several times within the same service? You could implement certain aspects of SSO, but Apigee is mostly for, again, like securing your backends by preventing, like by channeling the calls from that API to the corresponding backends. Because let's say you may have a truly distributed backend. Let's say you have a Firebase database, you have a Cloud SQL, you have legacy services that you want to all consolidate within a single API. Then you use Apigee. You could also do like versioning in Apigee, which is pretty cool. You can have like V1 of this API, but version 2 is for certain other users. You can keep it all of that transparent to the user, and then it allows for like the streamlined creation of those type of again like a proxy service in front of it. They talk about also like spike arrest policy. Again, you rate limit, to protect those backend services from massive traffic surges, like I was mentioning, limiting the rate of API calls, like Jose was mentioning, using private variables, you could do like a little bit of coding in Apigee, which is not that hard, but just minimal. And you can secure your API proxy using those industry standard protocols and configure traffic management controls. All of that in Apigee. Awesome. And then to wrap up, now we're winding down. Again, you can leverage the whole cloud ecosystem. Apigee, you could use it as a cloud gateway, like I mentioned. It's positioned within the Google Cloud ecosystem, enabling that seamless interaction with other powerful services. Like I mentioned, you could put it in front of your cloud functions or cloud run serverless containers. You could even read or write data to cloud storage buckets as part of an API. Can you believe that? You're like reading through your API, but you're actually hitting a cloud storage like JSON file behind your API, and you're like, yeah, sure, I want to just have something here, like in my cloud storage. You can do it through API Gateway. You can do that. Also, you could do external service callouts. Imagine you have, for example, let's say Apigee can use like those service accounts and IAM roles to securely call out other cloud APIs, enhancing the security, and also integrate the responses into the final client payload. So like I said, you may have like a very complex backend and a bunch of orchestration behind it, but you make it very easy for your clients by putting an API, by putting a API gateway via Apigee in front of that. And last but not least, you have the centralized logging and monitoring. Again, all API traffic and policy execution is integrated with the Google Cloud Observability for centralized analysis. You do a bunch of the login and all of that from one centralized location. So you will gain experience orchestrating a workflow where a single API call triggers actions and data exchange across multiple Google Cloud services, but makes it very transparent for your users. So that's what you're going to learn in this week, in week 6, in those labs, which is pretty good. That's it, guys. So yes, so the plan again, make sure to always continue hitting all of these labs. There's a bunch of labs, like I said. There's also some challenge labs in this week. So make sure that you hit all of those. We're going to give you one more week until next office hours to complete some of the remaining badges that you may have. And we're still working with the Google team to get you some of those vouchers. If you already have completed all the requirements, you will get a voucher thanks to being part of our community and whatnot. Okay. What other questions you may have before we wrap it up, and then we proceed to our next activity just to wrap up for the night. Any questions in the chat? Anything, Kevin? I don't know if you want to add something. I know we covered a lot, but there's a bunch of labs. You know, we kind of also wanted, as always, we try to make it interactive. We wanted to do something like that. So thank you everybody for joining. Please don't leave yet for those of you who are gonna go do the raffle, but at least we're gonna close the recording only for the content. So any other questions so we can address it? Otherwise, if no questions, then thank you so much, everybody. Again, please make sure to take a look at all the videos posted on YouTube from info session 1 through 6. This one will be up there shortly, and you can keep up with the things that we covered during this campaign. So thank you so much, everybody, for joining. Hopefully you can join us in upcoming future sessions where in future campaigns where we deal with more certifications. So please stay tuned for more news and activities from GDG Lawrence. Make sure to sign up for our community, GDG Lawrence, so that you can get abreast of the things that are coming up. Okay, thank you so much, everybody, and have a great night. Take care.
Hey, Roman, are we going to do a